In this video we're going to look at surds. I'm going to start off by drawing a rectangle. The rectangle is going to have a base of 4 units and a height of 3 units. So if we go ahead and do that, we've got 4 just here and we've got 3 just here. I might be asked to find the length of the diagonal of this rectangle. So if we take this one just here, we can now go ahead and use Pythagoras to find this length. You might already spot that that's a Pythagorean triple, so it'd be a 3, 4, 5 triangle. If not, we could define this length now to be x. So a squared plus b squared is equal to c squared, so we could say x would be the square root of 4 squared plus 3 squared. 4 squared is 16, 3 squared is 9, x would be the square root of 25. Some expressions have exact numerical values, so in this particular case we can say that x would be equal to 5 units. What I'm now going to do is take a unit square. So a unit square has side length of 1. This time we might be asked to find the diagonal of the unit square. So if I put 1 here and 1 here, we can go ahead and use Pythagoras to find this length. So if I do that, we'll say that this length now is going to be y. So writing in here, this is going to be y. A squared plus b squared is equal to c squared. So y is going to be the square root of 1 squared plus 1 squared. So y is going to be the square root of 2. When we're dealing with surds, we just say root 2. Root 2 cannot be expressed as an exact numerical quantity. It's approximately 1.414. We say that root 2 is a surd. A surd is an example of what we call an irrational number. Other irrational numbers that you might have met before could be pi or e. When we're talking about an irrational number, we can't express it as a fraction. So we can't have a over b where a and b are integers. An example of a rational number might be 4/5. So a is an integer, b is an integer, and that's just now a simple fraction. Another example of a rational number might be 9/10. So we're expressing this now as a ratio of 2 integers. When we have an irrational number, we can't express that number as a ratio, hence rational and irrational, of 2 different numbers. Let's look at another one. If we have, for example, 0.4 recurring, in the past we've seen that we can write this as 4/9. So that is a rational number. If we took pi, for example, pi is an irrational number. Pi isn't a surd, it's just an irrational number. So pi is approximately 3.142. Now we could say that it's approximately equal to 22/7. It's not equal to that though. Pi is a non-recurring, non-terminating decimal. It keeps going on and on. I think the guy who holds the world record, as we currently stand, has remembered 104,000 digits and just read them all back. So these are what we would say is an irrational number. And a surd is that. That's just a non-terminating, non-recurring decimal. So we can't put it in this form. We can give it an approximation, but we would leave it like so. As it currently stands, we say that this is an exact value. We leave root 2. If I give this as a decimal answer, I'm taking away the accuracy, and I'm also increasing the problems when it comes to dealing with these. So if we're adding, subtracting, multiplying, or dividing, it becomes quite a hassle if you've given a decimal approximation. So root 2 is about 1.414. Let's just look at that in the calculator. So the root of 2, let's write this in, and the calculator only gives us whatever it is, 9 or 10 digits. So 1.414 and so on and so forth. And that just keeps going on and on. So we say now a surd is an irrational number. Okay, let's look at some examples of surds. Root 2 is a surd, so let's write this here. That's a surd. Root 3 is a surd. The root of 4 is not a surd, as we can write this as an exact value, and we can write this as 2. Root 5 is a surd, and we can keep going on. So these are examples of surds, and this is not. What we're going to do in the video is work through a range of different features of surds and look at some of the things that we would be expected to do with them. So let's go ahead and start off. The first thing that we're going to do is look at simplifying surds. We'll then go on to adding, subtracting, multiplying and dividing, and then finally we will look at expressing a fraction with a rational denominator, and that's called rationalising the denominator. Before we get started, I think it's important to stress that if we have root a root A, as we would say it, rather than the square root of A is going to be a non-negative quantity. So we're looking now at non-negative quantities for A. If we had now the root of A multiplied by B, A and B are both non-negative values. So let's go ahead and look at simplifying surds. So if we take now a surd, root 8 is a surd. So let's write this here. After a while, you'll be able to simplify this by inspection. To begin with though, what we're going to do is look at prime factoring a number. So let's take 8. So if I prime factor 8, I can divide that by 2 and that will give me 4. I can divide that by 2 and it will give me now 2. So we could write that the root of 8 is the root of 2 times by 2 times by 2. I actually prefer to write this now as the root of 8 is equal to the root of 2 times by the root of 2 times by the root of 2. One thing that we can write now is the root of A times by B is now the same as the root of A times by the root of B. So we can just split these up. So what I currently have now is the root of 2 times by the root of 2 times by the root of 2. If we have root A multiplied by root A, we just end up with A. Now what I want you to do is just hit pause and just think about what this is saying. The root of a number multiplied by the root of a number is going to give you that number. So hit pause, try some numerical examples of that, and then pick the video up and we'll go from there. Okay, so hopefully you can understand how that works. So for example now, let's take quite a big number, well, relatively big number. If I have the root of 36 times by the root of 36, well, let's think about this now. The root of 36 is 6. 6 times by 6 is going to give us 36. So we can see the root of A times by the root of A is A. So let's look at this right here. Now what I've got is the following. I've got the root of 2 times by the root of 2. Well, that's just going to give me 2. So I can rewrite this now and I can write the root of 8 will be now 2 multiplied by the root of 2. So we'd say our final answer is 2 root 2. If you look at this on a calculator, your calculator, so let's grab this up, the root of 8 will give you now 2 root 2. You can see now that it's put in its simplest form for you. I strongly suggest you have a calculator well away from you, but just use it every now and then to check what you're doing. Don't rely on it, as you'll be expected initially in this unit to show your workings quite clearly. So that's a nice example. Now this one right here, let's take another one. Let's go for the root of 12. Now the root of 12, we could again prime factor this one. After a while you'll just spot it. Can we divide it by 2? Yes, the answer is 6. Can I divide that by 2? Yes, the answer is 3. And we fully prime factored it. So instead of the root of 12, I'm going to write this as the root of 2 times by the root of 2 times by the root of 3. So we can see now we've got the root of 2 multiplied by the root of 2 multiplied by the root of 3. So we can say that root 12, that will give me 2, we'll have 2 root 3. So what we're doing is looking at simplifying these surds. So if I put this into the calculator, the root of 12 is going to give me 2 root 3. Just out of interest, if we have now A, the root of B, I could write this as the root of A squared B. And I'm just going to leave you that idea just to think what I've done there. And that's kind of reversing the simplification process. And again, hopefully that makes sense. It's more important that you can work the way that we're working, but to spot this might help you when you're dealing with certain values. But again, hit pause, see what you can make of that. Now, sometimes it's easier to manipulate or simplify these by just using a bit of inspection. So if I said now the root of 48, yes, we could go ahead and prime factor this. But I'm looking at this thinking, well, 48 is 3 times by 16. So if I wrote this as the root of 16 times by the root of 3, well, I know the root of 16 is 4, so I'm going to end up with 4 root 3. And again, if you look in the calculator, the root of 48 is going to give us exactly that. It will give us 4 root 3. You could, of course, have prime factored it, but it just makes your life slightly easier if you can spot this. To begin with, I'm not expecting people just say, yeah, I can spot that, I can do loads of them. So another example might be, let's take the root of 200. you could go ahead and prime factor that, or you could write this now as the root of 100 multiplied now by the root of 2, or the root of 2 times by the root of 100. That's going to give me 10, so we end up with 10 root 2. And this goes back to the idea that if I square this number and multiply the 1 under the root now, we get back to where we started, and that's the property here. You will generally, though, work forwards instead of working backwards. So let's work through a few of those. Let's start off now with a root of 24. So let's take 24. So if you want to prime factor this, you can do. We know that this is going to be 8 times 3, so I could write this as the root of 2 times by the root of 2 times by the root of 2 times by the root of 3. Now at this stage, and again, if you want to, you can prime factor it. Let's go ahead and do that. I'm not expecting you just to spot that, so let's do that. And like so. So there we go, that's if I prime factored it. Now I can see that's going to give me 2. So automatically I can write 2 times by the root of 2 times by the root of 3. I want to put this in its simplest form. There's not a lot I can do now here. But remember what we've got. If we've got the root of a times by the root of b, we can write this as the root of ab. So this is going to give me the root of 6. So we'd end up with 2 root 6. And again, if you check your calculator, we can put the root of 24 in and it will give us now 2 root 6. So that's a property that you could use. If we took, for example, the root of 50, well, I'm looking at this thinking, well, that's the root of 25 times by the root of 2. That's going to give me 5, so I've got 5 root 2. Again, you could go down the 50, 2, 25, 5 and 5, and then write it out like so. You can have it root 5 times by root 5 times by root 2. That gives me 5, and I've got 5 root 2. So entirely up to you on how you want to look at that. Let's look at another one. Let's say we've got now, let's go for 6 root 12. So this time I've got a value outside of the square root. So what I'm going to do is just write this. I'm going to write this as 6 times by the root of 2 times by the root of 2 times by the root of 3. All I've done is written 12 as 2 times 2 times 3, which is prime factoring it. And we saw that earlier. We can sit here as well, 2 times 2 times 3. So I know that that's going to give me 2. So I've got 6 times by 2 times by the root of 3. 6 times by 2 is 12. So we end up with 12 root 3. So fairly logical, fairly straightforward. Let's look at 5 root 27. So I'm thinking to myself, 27, if I prime factored it, is 3 cubed. So it'd be 3 times 3 times 3. So we could look at this as 5 times by the root of 3 times by the root of 3 times by the root of 3. That will give me 3. So I've got 5 times by 3 times by the root of 3. 5 times by 3, let's write this in, is going to be 15. And then we've got root 3. Root of 300, in fact, let's say, let's go for 2 lots of the root of 300. So what I'm going to do is write this as 2 times by the root of 100 times by the root of 3. So again, I've spotted that I can split that up without doing anything crazy. So 2 times by 10 times by the root of 3. So we're going to end up with 20 root 3. So that's our answer. And again, if you wanted to put that through a calculator, 2 lots now of the root of 300, and we should now get 20 root 3. So that's looking at simplifying surds. Essentially, you're prime factoring and you're writing it out. Anytime you get root a times by root a, you simply write it as a. If you get the root of a multiplied by the root of b left, just use the property, but root a times by root b is the root of ab. Just one last one to finish with, the root of 32. Let's look at the root of 32. Well, that's 2 to the power of 5. So we've got now the root of 2 times by 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 the root of 2. So that's going to give me 2, that's going to give me 2, and that's going to give me root 2. So we get 2 times 2 times the root of 2, so we get 4 root 2. And of course, you can check that on the calculator. So don't be afraid, just write it out like so. Whilst we're here, if we're looking at the rules of indices and surds together, if we have now root of a, this is the same as a to the 1/2 power. So when you come on to calculus, for example, if you're looking at integration or differentiation, do realise that the root of a is a to the 1/2 power. So we've now looked at simplifying. We're going to move on to looking at the addition and subtraction of surds. So that was simplifying, and now we'll move on to those. So in the next video we will look at the properties of addition and subtraction and bring together some of the understanding of simplifying these to really condense some expressions. Hopefully though that's been a good introduction to what a surd is and how to simplify surds to put them in an easier form to work with. So a surd is an irrational number. That is, it can't be written in the form a over b, where a and b are integers, and we only have an approximation for the values.